All right. Okay, then we've got limits like this where we can't sub into, and if I've got a limit where I can't sub into because the denominator gives me 0, the idea was we have to get rid of the denominator by factorizing the numerator. Now if you just write equals, you know, x minus 2, x minus 1, you will lose a mark because you didn't write limit as x approaches 2. You've got to write that every single line until you have subbed it in. So now I'm going to sub it in. 2 take away 1 equals 1. Any questions? This one up here, I can see it's a power of 4. So I know that that is a difference of 2 squares. And then I can see that is a difference of 2 squares again. Now I can get rid of this, and then I'm going to sub in, you know, well, I'll just write it one more time. Okay, and then you sub in c. C plus c is 2c times c squared plus c squared is 2c squared. 4c. Any questions for that one? No. All right. Then we would have learned infinity. We said anything on, we said 1 over infinity is 0. So 1 over any infinity there is going to give you 0. That's a good point. 1 over 0. So 1 over a very small number. Or 1 over 0. Does anyone know what the answer to 1 over 0 is? 1 over a large number is 0. What about 1 over a small number? What would that give me? I know it's undefined, but the idea is if it's a limit, it can become something. So what's 1 over 0? 1 over a very, 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 very small number. If you don't know, if you're stuck, plug this into your calculator.
A big number.
A big number. Infinity. So 1 over 0 is infinity. 1 over infinity squared, 0. 1 over 0 squared, infinity again. In fact, this one is even larger than this one. So 1 on x squared, infinity, is bigger than the 1 on x is infinity. But anyways. All right. All good? Any questions about that? All right. So then the idea was we divide the numerator by the highest power of x in the denominator. It's not just the highest power of x. So that's in the denominator. So let's have a look at this. A. We said divide everything by x squared. So it'll look like this. Oh no, that's 2. They mix it up like that. It's annoying. All right, x is approaching to 2. I'm guessing this doesn't work. 4 plus 6 is 10. 10 take away 10 doesn't work. So for numerical questions, what do? We factorize the top. So x minus 6, x minus 2 on, factorize the bottom. X plus 5, x minus 2. Now these two cancel out. So the answer is 2 take away 6, negative 4, 2 plus 5, 7. B. As he approaches for infinity, I've got to divide by x squared. The highest pronumeral of the denominator. So x squared on x squared is, x squared on x squared is 1. 8x on x squared is 8 on x. 12 on x squared is x squared on x squared is 1. 3x on x squared is, and then negative 10 on x squared. Again, any questions for me just at that stage? All right, then when I sub in infinity into here, 8 over infinity, it all becomes 0, right? 8 over infinity, 0. 12 over infinity squared, 0. 3 over infinity, 0. 10 over infinity squared, 0. You've just got 1 over 1. Your answer is 1. C, do it again. Limit x approaches infinity. Divide everything by x squared. So 5x squared divided by x squared, you're left with 5. Minus x on x squared, you're left with minus 1 on x. I'm just going to write it. Just let me know if you have any issues with what I've written. Any questions about that? No, that makes sense. Last one, divide everything by not x cubed, by x squared, right? It's got to be highest denominator. So on the top you have left 5x minus 1 on x plus 9 on x squared, 7 plus 2 on x plus 1 on x squared. Okay, now what happens this time when I sub in infinity into here? 0, 0, 0, 0, but I've still got 5x on 7 as, so the next line is limit as x approaches infinity of 5x on 7. What's going to happen when I sub in infinity into here? 5 times infinity is infinity over 7. Your answer is infinity. Do you guys get that? Whereas these ones here were just constants. So when I sub in infinity, it's only going to affect these ones, which are zeros. Whereas when I sub in infinity into here, actually I still have an x, so 5 times infinity actually leaves you with infinity. Okay. Good job. Well, continuity. Yeah, why not? Determine whether the following functions are continuous at x equals 1. It does not say differentiable. So it can be continuous but not differentiable, or it could be differentiable but, oh no, if it's differentiable it has to be continuous. So let me just make that clear. It can be continuous but not differentiable. But if it's differentiable, then it will automatically be continuous. So if something is differentiable, it will automatically be continuous. But this question is just saying determine whether the following functions are continuous at x equals to 1. I would like to do these split functions, so we'll do b. F of x. If I sub in 1 into here, it gives me -3. This is for everything else. But the idea is when you're trying to find if it's continuous, that means there must be no break at x equals to 1. So what would happen is this function here, you would factorize the top, as always. These cancels out. So when you're going to sub in x equals to 1, 1 take away 4 does give you negative 3, which is the same here. So when you sub in 1, it does give you negative 3, so this is actually continuous. So B, f of x is continuous. Whereas with A, it's not continuous, and the reason why it's not continuous is because you have the problem at x equals to 1. Right? The only reason why you were able to sub it in is because you got rid of it. But the original function was this, not x take away 4. So A is not continuous. B is continuous because here it's not continuous at negative 3, right? There's a break, but it's saying at x equals 1, it is still negative 3. So it does become continuous again. Let's try to say that again. C, sub in 1 into here will factorize x minus, that's the same as this, isn't it? So x minus 4, x minus 1 on x minus 1, and then this is at 2. So when I sub in 1 into here, it gives me negative 3. When I sub in 1 into here, well, it's just 2. This is not continuous. Last one, let's check it out again. F of x. See how I'm kind of ignoring the less than and the greater than? Because the idea of continuity is that at all of these values, which is 1, 1, 1, they're meant to give you the same y value, irrespective of the inequality signs. So you sub in 1 into here, which gives you 3. Sub in 1 into here, 7 take away 4, which is 3. Sub in 1 into here, 5 take away 1 is actually 4. So it is continuous up to this stage, 3 and 3, like so these two are continuous. But then once we got the last one in, it became non-continuous, so it is not continuous. Okay. Simple substitution. So the reason why the first one was not continuous is because at x equals 1, there's already a problem. Just for a basic one like that. Now, you might say, okay, but Sam, isn't that the problem for this one? Yes, at x equals 1 is a problem, but it's saying at x equals 1, it does give you negative 3. So therefore, it solved the problem, which means A can now become continuous if written like this. All right. All right. Yeah, that's nothing. Yeah. Discontinue the Western distributed near Anzac Bridge. Apple Maps failed. Okay. Funny little thing, we don't need to worry about that. Let's keep moving, keep moving. Okay, so first principles. So we've got to do these by first principles. Maybe we'll recap question 3 first. Does anyone actually remember the formula for f dash of x using first principles?
F of x plus h minus fx over h.
Yeah, and do you remember what the beginning was?
Limit as x approaches h.
Close. As h approaches 0. Good try. So the denominator is 0. That's the idea with it. The h is going to approach 0. Of course, f of x is, we're going to do question 3. So f of x is 2x squared plus 3. From that, we know that f of x plus h, you just replace your x squared for x plus h, which looks like this, plus 3. 2 bracket x plus h squared plus 3. Okay, let me know if anyone's got any questions. F of x plus h is this thing, so I'm just going to expand it as I'm going to write it, so that becomes this. Minus f of x, which is this, all over h. Okay. Anyone confused on how I've got anything in this line? All right, and if you remember the rule, f of x should cancel out if you've done it right. So watch this, 2x squared minus 2x squared, gone. 3 minus 3, gone. What you should have left on the top is letters and numbers that have h's. The reason why you want them to have h's is because you've got to factorize your h out. Factorize your h out. All over h. Cancel your h out. Now you can sub in h is 0, which you get as 4x, which we all know is the answer, because what's the derivative of 2x squared plus 3? The derivative is 4x, but at least you got to prove it. Okay, now I can see one that I really want to do with you guys, which is like this one here. The reason why I want to do that is because if that was asked in an exam, there's literally nobody that could answer it except the ones that have actually done it before. So all of these ones, I mean, they're stock standard questions. These ones that have the exclamation marks, if you haven't done them before, if you haven't seen them before, there is no way you'll be able to do it. The ones that have the star are harder. So these ones are harder, but then the ones that have the star, impossible to do without it. The ones that have the single cross, even more impossible than this one. And the one that have the double, it's just ridiculous. To be able to do it, you've got to pretty much be thinking outside the box and outside that box and outside the other box. So that one's a very, very unique case. Won't be in an exam, but if you want to test yourself and try to get it out, I would recommend trying that out. But you will never get this on an exam. It's never been asked and will never be asked because it's just way too crazy. So we're going to try number 5 though. And I would recommend putting number 5, maybe starring it as well in your books, because it is a very unique way to use first principles. And if you haven't seen it before, then you'll never be able to get it out. All right, let's do this. Queenie, let's do it together. So we've got f of x equals root x. Then from that, we get f of x plus h, which is what, Queenie?
Root x plus h.
Then we know that the limit, we know that f dash of x is equal to the limit as h approaches 0, f of x plus h, which is just this thing, minus root x over h. Okay, and we're stuck. Why are we stuck, Queenie? What can you see that's making us stuck?
The root?
Yeah, what usually happens, what did I say is meant to happen with this root x? It's meant to disappear, right? I mean, your f of x is usually meant to go. And then what's another thing? Your numerator must have a common factor of like h, so that eventually you can cross it out. But none of that's occurring here. Okay, so I'm going to relay the question to you guys. And you've got to be very creative with the way you're about to say this. The first thing that will probably come to your mind might not be the exact answer, but then the second thing is probably going to be right for this. So you got to try to get it out to the second reason. But let's see. I want to get rid of my surds. So Queenie just said the surds are annoying. I don't like them there. So we've got to work out a way to get rid of the surds. What's the first thing that came to your mind?
Square, I think.
Yeah. So that would be right for a different style of question. And it won't be for these. When would you get rid of your surds? When you actually have equations. So when they're equations, yes, get rid of your surds by squaring both sides. You are correct. But that is not the technique when you're trying to deal with one side. When you're dealing with one side only, there's another way to get rid of your surds, and that's the second way that I said that should come to your mind.
Rationalize. I don't
Yes.
know. Yeah.
Yes. Smashed it. Rationalize. So we're going to rationalize. Now, what's the way you've been taught to rationalize before? Only rationalizing the denominator. But to do this, you're going to rationalize, obviously, the numerator. And there's no problems with that. No one said it has to just be the denominator. It's just that you usually don't want surds in the denominator. Now, in these questions, we actually don't want surds in the numerator. So look what happens. Queenie, do you know the answer to the top when you're going to expand this? It's just like a difference of two squares. So.
X plus H minus X.
Yeah, exactly right. X plus H, when you expand that, minus, expand that, it's just going to give you X. The bottom, you're left with this. And then, what happens to the top now? X, take away X, gone, as we needed it to be. And we have H finally. So your next line, you've got this. And then you can cross out your H now. You're left with 1 on root X plus H plus root X. You know what H equals to? H is 0, sub it in. You're left with root X plus root X. So what's the final answer, Queenie? 1 on?
1 on 2 root X.
2 root X. Let's see if you are correct. The question was why equals root X. You have to change that to X to the power of a half. What does Y dash equal to?
Half X to the power of negative half.
And then negative half goes in the bottom as positive half. And 1 over 2 root X. Smashed it. And that is the only way you're going to be able to do that. Nada, I can tell you, and Novak, your schools pretty much test this every single year. So this is the one you want to know. The basic ones are not really tested at your schools. And same thing, actually, Queenie, your school, same thing. They test the square root ones a lot. And the only reason why they test it is because it's not really in textbook questions. So this one you've either seen it in exam questions and you know what you're doing. Otherwise, there's no way you're going to think of rationalizing if it's the first time you're doing it. Brilliant. Keep a note of that, especially the one that I just said, like it'll be in your exams. Guarantee it. All right. And they'll all work the same, otherwise, you know, you're going to rationalize this. Okay. Okay, so these ones here, I'm going to emphasize them because a lot of students do believe these are quotient rules, which will work. So quotient rule would work, but you don't need to do quotient rule for these questions because there's only a single expression in the denominator. So you might want to make a note of that as well. If you've got a single expression in the denominator, you don't need to use the quotient rule you can split the fraction. So this would just be 3x to the power of 4 on x squared minus 2x cubed on x squared. So when you simplify that, you're left with, 3x squared take away 2x. Then you just differentiate that. So which is a lot easier than trying to go ahead and start doing, quotient rule. But I will do quotient rule just for argument's sake. Y dash equals U dash. Oh gosh, all right. 12x cubed minus 6x squared V. You're already seeing what a mess this is going to be. V dash U on V squared. Then you're going to factorize. Okay. Oh, this is going to be craziness. All right, let's try it out. So actually, I will expand and then factorize. So this will give me 12x5 minus 6x4 minus 6x5 plus 4x4 all over x4. 12 take away 6 is 6x5 minus 6 plus 4 is negative 2x4 on x4. Then you factorize your x power 4 out. You're left with 6x take away 2 on x power 4. These cancel out and you are done. But what a beautiful mess you have created. So just keep it in mind, maybe make a note of that. If I've got a single expression in the denominator, I probably should use splitting the fractions instead of quotient rule. All right, I'll just do question 4 up here. 2x squared root x on x plus 3x root x on x, y equals, okay. If I've got an on x now, I can just cross out this and this. I can cross out this and this. I'm left with 2x root x plus 3 root x. Yeah, I think this will be Anouk, 2x root x plus 3 root x. Okay, this one here, I feel like you can differentiate that. So what's the derivative of 3 root x?
You have to use index laws to make it x to the power of half.
Yes.
And then you minus 1. So it's going to be minus half.
3 over 2, you got to bring the half down.
Yeah.
And then x and then minus half. Yeah?
So it's going to be 3 over 2 root x, right?
Yep. I'll do that. Now what about this one? 2x root x.
Can you get rid of the x?
How?
No. Because differentiation of x is 1.
Ah, wrong. Very bad. And that's why I picked you. Because I want you to know that that would be not allowed. Try not to do that. Can anyone tell me why I'm trying to emphasize that so much? That would be wrong for that specifically. Think of your rules.
Could you use the product rule?
Yeah, that would be a lot better. Right? At least you'll get the right answer. So you have to remember, you can't just go ahead and start differentiating things. You can only differentiate if you've got a single x. So like, look, that I can't differentiate. I simplified. Single x, yeah, go ahead. Yep, single x, yep, differentiate. You can't do them like this when they're multiplied, x's and x's. You would have to use the product rule. But I don't want you to use the product rule. Can you see that this case, and it's not every case, it's just this one because it's an x root x. Can you see that I can write that as x times x to the power of a half? And what can you do when your bases are the same? You can add your powers. And that, can you see, Anouk, that's a lot easier to differentiate than it was to bring in product rule. And the only time you guys are going to obviously get used to knowing to do that is through a lot more practice. That usually takes about 2 to 3 weeks of practice of calculus to realize these special cases like this one here and the splitting the fractions cases. But yeah, no. So product rule, at least you got the right answer. But to avoid using the product rule for that, you can see you can use your index laws, rewrite it like this, and then it's really easy. 2 times 3 over 2, that's 3x a half plus what you said before. And then 3 root x plus 3 on 2 root x. All right, any questions about that one there? All right, whoops. Let's move on. We just did these. Yeah, can you see how they're all the same questions over and over again? Let's recap these from last week. Chain rule. So y dash for question 1. You bring this. Actually, I'm just gonna, since we've got only what 10 minutes or something, we're gonna start from the top. All right, Aiden. Let's go. Chain rule. Let's differentiate this. So
Yep.
Bring the 6 down.
It'll be 6 bracket x squared plus 1. To the power of 5
Times. You have to now differentiate the inside.
times 2x.
Done. Thank you very much. Andy, you're next. This one here. Andy?
Yeah.
Yep, go ahead. Y dash.
Y dash 35.
35, bracket.
3x plus 4. Bracket 4 times 3.
Good job. Done. Next. Anouk, question 3.
Yeah. So it's going to be n ax plus b times a.
Yep. Emily, question 4.
You have to, since it's a third, we don't want a third, so it equals bracket 25 minus x squared to the power of a half.
Beautiful. Y dash.
Y dash equals to half bracket x squared minus x squared bracket negative a half times 2.
Oh, come on. Times negative 2x. Don't forget, that's got to come down, reducing power by 1 only. So you can't just say negative 2, negative 2x. Yep, and then half times negative 2 is this. And just for some fun, This goes back in the denominator as positive half, and then it's a square root, so you should be able to get it to this step. All right. Good job. All right, who's next? Another. Come back to the product rule. All right. Now that you're going to do question 1. Oops. 1. U, V, using the product rule.
It would be 1 times x minus 10. And then plus 4. And then x minus 10 to the power 3. Plus 1. Times 1.
Yep. And then times. That's
X.
dash times x. Beautiful. And then what's your common factor?
X minus 10 to the power 3.
And then you're left with x take away 10 plus 4x. And you are done. Thank you. Good work. It doesn't always happen, but in this case, you guys can probably see 5x take away 10. There's also, again, another common factor of 5, so you got to take it out. But actually, being extension students, keep an eye on that. Okay, perfect. Who's next? Novak. Question 2.
Yeah.
Novak, you might as well just do question 3. That's you and... All right, go ahead. Y dash equals?
It's uv dash plus
Yep.
v dash u.
U v dash plus v
vu dash, sorry. So then that would be x.
Yeah. Okay.
1/2 x plus 3 plus, but it's x, so it's just 1.
Yeah, but what about your power?
It's minus 1/2
Yeah. Plus.
plus uv dash plus vu dash, so that means x plus 3 to the power of 1/2.
X plus 3 to the power of 1/2. Now, if some of you are confused about what has happened here, Novak has done u v dash plus u dash v, or vu dash. So he decided to differentiate v before u, but the way we've been usually doing it is differentiating u. But the order truly does not matter, because 2 plus 1 and 1 plus 2 will both give you the same answer, right? And we don't really care. So I will accept his answer because he hasn't done it wrong. All right. But if you guys are more comfortable writing this one first and then this one, just do it. It's the same thing. Okay. Then we write x on top, and it's going to look like this. And now what are you going to do?
Factorize?
I don't think you can factorize like that. Not like that. Okay, it's a fraction.
Yeah.
Not really. Maybe in the first line here, if you want to use index laws and factorize.
Yeah.
But it's not the way I was saying it last week. Think about it. What would you usually do? You've got a fraction.
You would do normal fractions.
But what do you mean? You've got one fraction plus another fraction.
So find a common denominator.
Yeah, that's the word I'm looking for. So multiply this across, find your common denominator, which is obviously 2 root
x plus 3.
Now, what's 2 times this? Well, that's just 2. What's root x plus 3 times root x plus 3?
X plus 3.
And then your answer is 2x plus x plus 6. If you wanted to factorize, you can. That's it. Okay. Last two. Quotient rule. Shania, let's do question 1. U v y dash equals.
So that would be 2 and 2x plus 1.
This one's really important, the order.
I mean minus 1, sorry.
Yeah, fair enough, but minus.
2
Yep.
and 2x plus 1.
Yeah, it must go. So with the other one, I did say it doesn't matter, like 1 plus 2 and 2 plus 1, whatever, that equals 3. But because quotient rule, it's a minus case, the order does matter. It must be derivative u, then v, minus derivative u, v, sorry, then u. But anyways, all over.
2x plus 1 square. I mean minus 1 square. Jesus.
And then 4x, take away 4x, gone. Minus 2, minus 2. I think it's done. There's nothing for you to do there. It's finished. Good job. Last one, Queenie. Let's end it. U and V. Oh, that's going to be a nice hard one to do. Yeah. Nah, I'll leave that one for next week. It's going to take a little bit longer. No, I'm going to leave it there. All right. I've got to start on the next class.